Okay, so today we're going to start talking about concentration of solutions. So, the word concentration, the concentration of a solution is a measure of the amount of solute in a given amount of solvent or solution. So, concentration is a ratio. It's any amount of given solution has the same concentration. The opposite of concentrated is dilute. And I think I talked about this in the solution process, one of the videos. So these terms are unrelated to the degree to which a solution is saturated. A saturated solution of a solute that is not very soluble might be very dilute. So the mathematical operation we're going to learn today is molarity. And molarity is the number of moles of solute in 1 liter of solution. So for example, a 1 molar solution of sodium hydroxide contains 1 mole of NaOH in every liter of solution. So it will be 1 mole of NaOH all over 1 liter of solution. Be the same thing as saying 1 capital M NaOH. You can't have lowercase m. We're going to learn about lowercase m, and that is a whole nother type of concentration. So the symbol for molarity is capital M. The concentration of a 1 molar NaOH solution is written as 1 capital M NaOH. So the figure below illustrates the procedure for making a 0.5 molar or 0.5 M solution. So we look here. So this 0.5 M, if we want to make this, and say this was 0.5 molar, and we'll say NaCl. So it says add 0.5 moles of solute to a 1 liter volumetric flask, half filled with distilled water or deionized water. All right, so we look at this 0.5 moles. Well, how many grams are we going to have to get of our solute? So you'd have 0.5 moles NaCl and multiply by that by its molar mass to figure out how much or how many grams of NaCl we would need to put into our volumetric flask. So, Na is 22.99 plus 35.45, and I would get 58.44 times 0.5, and I would need 29.22 grams of NaCl. Okay, then we're going to swirl the flask carefully to dissolve the solute, and then we're going to take a wash bottle, fill the flask with water exactly to the 1 liter mark, and it's right about there where they stop pouring. You'll see at the meniscus there. Then we'll either put, usually we have a stopper we'll put on here that we could shake it thoroughly. So now our formula. So we have molarity, capital M, equals moles of solute over liters of solution. I'm going to tell you now, a lot of these problems will give your solute in grams, solution in milliliters, so you'll have to change those from grams to moles and milliliters to liters before you can divide your two numbers, which is not a big deal. So we look here. First example. It says, IV saline solutions are often considered to patients in the hospital. One saline solution contains 0.9 grams of NaCl in exactly 100 milliliters of solution. What is the molarity of this solution? So I know by looking at this, I can't just divide these numbers. I need to change some things. So I need to change 0.90 grams of NaCl to moles of NaCl because I know NaCl is my solute. Once again, 22.99 plus 35.45 will give me 58.44 grams of NaCl. So 0.90 divided by 58.44, and I will get 0.015 moles NaCl. So we'll keep this for a little bit, this number. Now to get our liters of solution, so we have 100 milliliters times 0.001 liter in 1 milliliter. So I get 0.1 liters. So now capital M equals 0.015 moles over 0.1 liters. So I divide by two numbers, and I would get 0.15 capital M for molar. Okay, household laundry bleach is a dilute aqueous solution of sodium hypochlorite. How many moles of solute are present in 1.5 liters of 0.7 molar NaClO? So, when we give us one like this, we have to find moles. Let's always start with our volume. So we have 1.5 liters NaClO. Now, I know we could use this right here. A couple of slides before, we said 0.70 molar would be the same thing as saying 0.70 moles of NaClO all over 1 liter of solution. So that's what we're going to plug in right here. So we have 0.70 moles NaClO over 1 liter of NaClO. We'll just solution, that's fine. So to figure out our moles, we would have 1.5 multiplied by 0.70, and we get 1.05 moles NaClO. Okay, so the last question I have here, that will end the video today. It says how much water is required to make 1 molar aqueous solution of NaCl if 58.4 grams of NaCl are dissolved. Okay, so we'll cross off a few things right away here. All right, so first off, 1 liter of water, all right? It's definitely just not going to be 1 liter of water, so you can cross that off. It's not going to be 100 milliliters of water. It's not going to be 1 kilogram of water. Right, the only one that makes sense here, right, how much water, because we're going to have our solute. Now, obviously, this is not going to be drawn to scale. So in our volumetric flask here, we're going to have, we'll say we have water up to here. Then I put in NaCl. Now, I'm already filled up to here. I only need to get to here. So I'm definitely not going to put 1 liter, like I said, 1 kilogram, or whoa. Sorry about that. There we go. Okay. So definitely not going to be 1 kilogram. Definitely not going to be 100 milliliters. But we're just going to have enough water to make this 1 liter solution. And this ends our video on molarity. Have a great day.